Hello guys. Set matrix 0. We got the question. We got this question. Now the question says that we got the matrix, and if the element is 0, the entire row and the column will be 0, like this. This element is 0, the entire column and the entire row is marked 0. So what is the approach? The approach is like we'll be traversing all the elements of the matrix, and if we get to 0, we'll immediately filling all the zeros of the rows and columns 0. So like the first approach we'll get like this only, but here is the when here's the downside. Actually, we get this 0, then we have put all the zeros up to the column and the rows, but again if we traversing here, we again got the 0. So according to the algorithm, we would have to fill this column 0, so that we don't want. So the next thing we can think is like we'll store the position of all the zeros in certain data structure, so that after getting all the position, we'll put the zeros. Like after we will get all the position of the zero, and then we'll traverse to the that data section which we are storing the position, and we'll mark 0 whenever we get the element at the position. So here we'll be using the array, because so how will be using the array, because the position of the 0 here we can say is 1, 1. So 1, 1 is not, we cannot store 1, 1 as one element in the array. So what we'll be doing is we'll be traversing, like this is the 0th element, this is the 1th element, this is the 2nd element, 3rd, 4th. So the 4th element is the 0. We'll mark the 4th element, that array, as 0, and then again we'll be traversing all the way up to the last element of the matrix, and whenever we get the 0, we'll mark that the position of that array is as 1, because the initially we will be getting all the positions filled with 0. So whenever we get the 0, we'll mark that position as 1. So let's go with the coding part. We'll get it. So what we are saying that we'll be having the array that holds the position of all the zeros. So what will be the size of this array? So we can get 0 all over the matrix. So 1, 2, 3. So basically it's the size of the matrix only. So matrix, let's reduce it to m so that it would ease the typing process, into m of 0 dot length. So here we have created the data structure, that is array, of course, which will be storing the position of all the zeros. Now we'll be traversing matrix, right? M of 0 dot length and j plus plus. So if we get m of I of j equals to 0, we will mark, let's say we need to traverse in the array also, so we'll generate one key, let's say. So we'll whenever we get the 0 element, we'll mark that position, that is fourth index as 1, and yeah, k plus plus, so that the index of this position holding 0 must integrate. So let's show you if it is storing the position of the 0 or not. So let's say that I equals to 0 or less than z dot length plus plus. So system dot out dot print z of I plus space. Now if we see, we get the one position at the fourth index, right? So up till here the code is working right, our algorithm is perfectly working. Now we'll be again traversing int I equals to 0, I less than m dot length I plus plus. And now for int j equals to 0, j less than m of 0 dot length j plus plus. Now again, first of all, mark this as 0. Now if we get m of I of j equals to 0, and like if we get, like we don't really need to check this condition, we just need to check this thing, z of k equals to, whenever this thing comes in, what we will do, those two for loops which will fill the entire row and column. Say L equals to 0, right? L less than m dot length and L plus plus. So m of L of 0, sorry, of j equals to 0, and for int, let's copy this. So now, yeah, right, here it will be I and L, right? So whenever we get the position of 0, so we'll mark all the rows and column as 0 with these two puts. So I guess it's done. No, it's not done. We need to, we have forgotten this, yeah, so we need to integrate k also now. So I guess that's it. So here it is accepted. Let's comment this out now. So here you can see it's faster than 50.46%. So this is the basic approach which you can use. In the driver list, the constraint was that there would only be positive elements in the matrix, but here the lead code says that it can be filled with the negative elements. So the brute force approach, I guess what I can found is this only. So thank you.